This video was produced by Virginia View, a consortium dedicated to promoting remote sensing outreach, education, and research through funding by the America View Consortium. This video was developed in partnership with the Virginia Geospatial Extension Program and GeoTED UAS. Its contents are solely the responsibility of the authors and do not necessarily represent the official views of America View, the USGS, or other partners. The mention of trade names or commercial products does not constitute their endorsement. In this, the final chapter on supervised classification, we demonstrate creating a signature file and conducting the supervised classification. There are many other techniques and algorithms not mentioned here to conduct a supervised classification. Begin with the 11-band composite Landsat 8 image created in Chapter 15, set to natural color, and the training sample shapefile created in Chapter 23, symbolized to match our information classes. We'll begin with a maximum likelihood supervised classification. To use the maximum likelihood tool, we also need a file with the spectral signatures for each informational class, a signature file. Go to the Analysis tab and select Tools. Search for and open the Create Signatures tool. The input raster bands is the composite image. The input raster or feature sample data is the training samples shapefile. The sample field should be class value. Navigate to the folder where you want to put your signature file and name it. You can use the default location if you like. And click Run. When the tool is finished, you'll see a completed successfully message, but no new file in the contents. We'll retrieve the file in a minute. Now we can conduct a maximum likelihood classification. Go to the Analysis tab, Tools, and search for and open the Maximum Likelihood Classification tool. For the input raster bands, select the composite image. The input signature file is the signature file that we just created above. You'll have to navigate to find where you put it. It has a .gsg extension. You can rename the output classified raster if you like. Leave reject fraction at 0 because we want all cells to be classified. Under the Environment tabs, we won't change any settings, but they can be changed depending on the needs of the final project. Now select Run. When the tool is finished running, the new layer is displayed as usual with random symbology. Go ahead and fix that up to reflect our informational classes. We'll assess the accuracy of this maximum likelihood classification in Chapter 25, Accuracy Assessment. We'll use this maximum likelihood image, but we'll also need to calculate the percent of total area and the number of hectares for each informational class. Let's do that now. Using the same techniques from Chapter 1, calculate the percentage field. Also add a hectares field. Each cell is 900 square meters or 0.09 hectares, so that's a simple calculation of count times 0.09. Refer back to Chapter 21 if you need to for calculating the percentage field. Now we'll demonstrate two additional classification processes available in ArcGIS Pro. Geoprocessing tools provide additional options for classification. Under the Analysis tab, Tools, search for and open the Classify Raster Spatial Analyst tool. Looks like we need to provide an additional file, a definition file. What's nice about this tool is that we don't actually have to use the maximum likelihood tool if we create a definition file based on the maximum likelihood algorithm. So let's create that definition file. Go back to Analysis Tools, search for and open the Train Maximum Likelihood Classifier tool. Enter the composite image for the input raster, the training samples file, name your output file, and store it where you can find it. Select Run when you're ready. Now go back and open the Classify Raster tool. Input the composite image, the definition file, and name the output. Select Run. Notice the new layer in Contents has the correct symbology. Because the training sample shapefile was used in the creation of the definition file, the symbology nicely carried over to the new image. However, this method does not provide a cell count, so calculating the number of hectares or the percent of land use requires additional geoprocessing steps, which we'll demonstrate in the next section. The third technique we'll use is the image classification wizard. We briefly reviewed the image classification wizard in chapters 21 and 22. It can also be used to do a supervised classification. Go to Imagery and select Classification Wizard. In this first dialog box, choose Supervised under Classification Method. Then under Classification Type, choose Pixel-Based. For Classification Schema, we have 4 options. But since we created a classification schema in Chapter 22, browse to its location and add it. Under Optional, add the training samples shapefile and select Next. Had we not already created the training samples, they could have been created here. Select Next again. Maximum likelihood is not an option in the image classification wizard, so for demonstration purposes, select Support Vector Machine for the classifier and click Run. Once complete, a new layer with the appropriate symbology appears because we again use the classification schema. But be aware, the image is only available in this project. So if completing an accuracy assessment with this image, the accuracy assessment must be completed within this project. Or you can export it into a permanent file by right-clicking on the file name and choosing Data, Export Raster. We won't demonstrate that here. While this image file does have an attribute table, it doesn't have a count of the number of cells associated with each informational class. From these results, we need to use additional geoprocessing tools to calculate the number of hectares and percent of land use. Let's do that now. To calculate the number of cells per informational class, go to Analysis, Tools, and search for and open the Cell Statistics Spatial Analyst tool. The input is the preview classified image generated from the image classification wizard. Name the output raster, and from the list of statistics choose Sum. Then Run. Open the attribute table for the new file that shows up in Contents. You'll see a cell count here. Although the classification scheme numbering has changed, the relationship of the value field to the informational classes can easily be verified and corrected. Add the remaining fields for practice: the class name text field and the associated class names, the percent and the hectares fields, and be sure to calculate the numeric fields to populate them. This concludes the chapter on supervised classification. We'll use the file created with the maximum likelihood geoprocessing tool in the final chapter, Chapter 25, Accuracy Assessment.